Siva Karthik, Nitish. I would kindly request you guys to join from official ID of IIT Madras. And if you are not from this degree, as this is open to all, kindly just let me know in the chat. Okay, just let me know in the chat. Hi Brijesh. Yeah, Shitish. I think there are a few students who are not from our degree itself. As we have opened this to everyone, education
Yeah,
is free.
it's free for everyone. Yeah, yeah.
Yes,
I think
for all of you guys.
every
Session.
those who are not from our RT Madras, then no problem. We will give you certificate. But
Right.
let us know that you do not have our official RT Madras student mail ID.
Yes, do let us know that you are not having an official ID, because we will have to track you down to give you certificates. People are joining in a bunch. Okay. Okay. Let's see. Let's take the number to 30. Call your friends, guys. This is the first session ever, right? So call your friends. Let's take it above at least 40, 40 to 50 people, right? Share this with your peers. Share this with your friends. Take their mobile phone and just hit that link. Yes, yes, Brijesh. Even we are excited to conduct this. Utkarsh, try to open your video now. Mhm. One more thing. Let me make this professional. What else? What else do I have? Okay, 4 minutes and then we'll start. Call your friends. Call your friends. Email them, text them, WhatsApp them. Just bring them here. आदित्य, व्हाट्सएप से अपने 2-3 आईडी से ज्वाइन हो जाओ. Okay. Chalo guys, since we have crossed the mark of 40, I have a small request before we start. Video on kar lo. Open your videos just for a few minutes. Let's see who are we talking to. Who are the students here? Come on, Chinmoy. Come on, Daksh. Come on, Kshitij. Come on, Hariom. By the way, Hariom is our founder, huh? Founder of our society. Come on, Ayush. Kinjitha. Come on. Nizal. Gaurav. Vastik. Come on, guys. Open your video. Let's see your beautiful faces. Shreyash, Kush, Brijesh, Krish, Krishand, Prasad, Chinmoy. Okay, okay, okay. Open your videos, guys. Open your videos. Come on, come on. Nice, nice. Okay, let me pin him.
Kshitij, can you just type something in the YouTube chat so that I can make you moderator over there?
Okay.
Okay, let me try.
Give me the link now. Give me the link now.
Yeah, I've given him the link.
Where?
In the WhatsApp, in the WhatsApp.
I don't see the link. Wait a second. Wait a second. I don't have the link. Any from the chat, guys. Any attendees? Just, uh, just give me the link now. I'll have to find it somewhere.
Can you just let me know if the live stream is started or not? It's
Oh,
started.
I
It's
from the
it's
chat,
started.
Okay.
It's
guys. Any
started.
attendees? Just, okay.
Kshitij, I've made you the moderator. Now you can do it.
You can do it
And like you can
yeah.
moderate the chat over there. And so, okay, I'll take a leave. Like I'll be in the meet, and whatever problem persists, please call me. Like dial me once. Thanks.
Yeah, I will contact you.
Yeah, sure.
Any problem? Yeah, I will contact you soon.
And like you can moderate.
I guess we have reached the threshold and it's 7. So should we start, guys? Tell me. Should we start?
Yes, yes, yes.
Yes, yes.
Yeah.
Yes.
Okay. Can someone share the PPT, please? Can someone share the PPT, please? Okay. Yes, Venkat. Uh, any serious doubts? Because we'll be taking the doubts and queries in the end, anyway. So let me unpin him. Okay. And host, kindly start showing us the PPT. Let me remove this. Better. Utkarsh, Utkarsh.
Yeah.
Mhm. Okay. Yep.
I think Hariom is going to share the initial level PPTs. Actually, I have the Arduino and workshop related PPTs. So about your society and all, I think Hariom have.
Yep. Let's start now. Let's start. Let's start anyway. So I just need someone to give me 1 second.
Okay, so initially you will give your intro about your society and all, then we can start the
Yes, yes,
workshop,
yes, yes,
right?
yes. Yes, sir. Yes, let's start about it. I'm just ensuring that we have everything we need.
Ah, okay, no problem. Just check it out.
Yes. Okay, so check on, is my voice clear, guys? Is my voice clear? Come on, you can open your mic and tell me, is my voice clear?
Yes.
Yes,
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 sir.
yes. Okay. Okay.
yes.
Little bit lagging. Okay. Is it lagging, enough for you to not comprehend what I'm saying, or is it lagging so much that I'm not audible?
I think not lagging. You can continue.
Clear, clear.
Okay, okay. Let me check it for you guys once, because we don't want it to go haywire.
Uh, okay, whoever is the host, just change your this thing to tile views. Okay, I'll do it. I'll do it. It's fine. I'll do it. Sorry. And co-host, so whoever is sharing the screen, please pin it. Okay, so that it will be visible to the YouTube viewers.
Okay. Let me pin it then. Okay. Hey, I'll give it back to you, Utkarsh. Okay, I'll give it back to you in a minute. Let me. Daksh.
Yes, yes.
Hello.
Hello.
Let me share it for a few minutes. It's, Let me share my screen for the introduction part, and I'll give it back to you. Right? Okay.
Okay.
No, it won't. It won't happen anymore. Okay. Okay. It's 7 and 5. I guess everyone is here. Let's start it then. Is my sharing visible? Okay. Chalo. Okay. So, good evening, guys. I am Suchit Sharma. I am the host. I am just anchoring this event, and I'll pass it back to Utkarsh later on. Okay. So let me explain what we are going to do. We are SAHYOG, a club founded under Namdafa, right? We help students teach each other and students who are underprivileged by any means necessary, whether be it offline or online. And this event is brought to you by Namdafa House. This is day one, the introduction session to our 4-day workshops. The as you guys would have seen the title in this poster that we shared, introduction to Arduino. We'll be covering on basics, and any doubts, any queries that you guys have will be answered and resolved at the end of the workshop. Let me give the access back to Daksh so that he can share the PPT for it. Here we have Utkarsh, who will be hosting and explaining the session. He is the main host of this event. Everyone, at least just say hi to him. Thank you, Bhaiya. Thank you, Utkarsh Bhaiya. Okay, so he's in diploma level,
Hi,
and this
Kashmir.
genius. and this
Thank
Hello,
genius of a guy
hello,
Hi,
will
Priya.
be
hello
taking
all.
the session today. Uh,
thank you,
so
Trevor.
Daksh, take on the access of sharing the screen, and now on to you, Utkarsh.
Okay. So, hello, myself, Utkarsh Srivastav, and right now I'm pursuing my BS degree in electronic systems, and I'm currently in the diploma level. And in today's workshop, basically, I will tell you guys about the Arduino and what is the microcontrollers. It's a basic kind of workshop. I'm expecting that many of them are know about the Arduino very well, right? But yeah, there is quite possibilities that many students are there who even don't know that what's the Arduino and the microcontroller, but they are very enthusiastic and curious about it, right? So I designed a lecture or session in a such way that everyone can easily understand and get what the Arduino and how we can develop projects and all. And about me, I'm working with the Arduinos and the microcontrollers from the last 6 to 7 years in my class 8. And after the class 8, I started on making the projects on it. And then in the 11th standard, after I started with microprocessors, like you heard about the Raspberry Pis and all, Raspberry Pi,
Utkarsh,
and Banana Pi.
Utkarsh, excuse me,
Yeah,
Utkarsh. I'm sorry to interrupt, but
okay, okay.
kindly bring the mic closer because the participants are not able to, hear your voice so clearly. Your, audio is low. I guess the input is low from your end.
Okay, 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 okay.
Either bring the mic closer or just speak, loudly.
Okay, okay. Okay, okay. The technical thing happens.
Just
Okay, now,
shout, just shout.
okay. So now it is clear, right? I'm asking about now it is clear. Okay,
Participants, it's
thank you.
your section.
Yeah,
Yes, yes.
thank you. So yeah, it's today is the basically is a pre-check workshop. I will try to my best and seeing the number of participants, 82 right now, and it's a very glad chance for me. And also, I'm thanking the entire SAHYOG team for inviting me as a guest speaker over here. And I will share my knowledge and my experience, whatever I have, to you, all of you guys. And so, without wasting any time, so I will further proceed. Okay, so I will share my screen. Suchit, okay,
Yes.
I'm going to share my screen. Okay,
You share it, I'll pin it. I'll pin it.
yeah. Yes, yes. I think I think it is visible for all, right? Okay,
Yes.
so just give a sec. So,
Guys,
guys,
any doubt will
it's
be addressed at the end of the session.
yeah.
And
And
I kindly now request each and every one of you to maintain, microphone silence at the moment because it will really interrupt the flow of the host. I'm myself interrupting the flow. I'm sorry, Utkarsh, but uh, I hope you guys will. I hope you guys will maintain silence and decorum of this meet.
okay, so we will start about the introduction part. Basically, I will tell you the flow of our today's workshop. We will discuss about the Arduino, right? Many of you heard about the Arduinos. Maybe some of them are actually working on the projects or did in past time. So, and what is the microcontroller? Also, we will see the various aspects of the microcontrollers. Okay, basically, microcontrollers are
Utkarsh, you got muted. You muted yourself, I guess.
Okay, 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 okay. Oh, okay, okay. Sorry, sorry, sorry. I think there is a kind of now. Voice is clear. Voice is clear, right?
Yeah, it's
Okay,
clear
thank
now.
you. Thank you.
Yes.
You can proceed.
Yeah, sure. Okay, okay. Sorry for interruption. Okay, so I will explain again. Huh? And basically, what is the Arduino? In today's workshop, we will discuss about the Arduino. That what is the Arduino and what is the microcontroller. Microcontroller is the basic or the core thing of the Arduino. Basically, Arduino is a kind of company which makes different kinds of development works. Okay, and Arduino is the product of that particular company because it's very easy to use, easy to code, and all. So it is quite popular for the electronics enthusiastic persons. It is very popular, and also there's a lots of different kinds of microcontrollers are there because microcontroller market is very wide. Actually, if I'm not wrong, the STM is the company which is making the microcontrollers, especially
Correct.
development boards as well. So STM company has 500 plus different development boards. So it's a quite long market is there. And over and all after that, we will also see the uses of microcontroller means where it actually use or what kind of projects we can do with the help of these microcontrollers. So now we will move forward. See, this is basically about many of you
Utkarsh,
see
the presentation is not visible. I guess its sharing has been stopped.
what.
I think you have
You,
unshared the screen. We cannot see the presentation.
yeah.
But I don't. You are not allowed to share screen right now. It is showing, bro. Technical team,
Okay.
please check it. It is showing
Okay.
you are not
It's
allowed to
been,
share it.
it has been it has been sorted. It has been sorted. It has been sorted. No worries, no worries. It has
Okay.
been sorted.
Okay. 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 Let me share again. Okay. So it starts sharing, right?
Yeah.
It start.
Now it's little.
Oh, okay. Sure. Thank you. Okay. So let's move forward. So basically, what is Arduino? This is a picture of Arduino. Many of you, as I previously told, worked with it and all, but it is a very small size device. The size of Arduino is like it is easily fit on your palm. Okay, and it can handle the several tasks. Task means what is the task? Task means there's a kind of events. Okay, like I'm giving you an example. Like when you entered in a room, okay, and there's a bulb which is automatically turned on after detecting you. So the thing is, who one is doing this particular task, right? So the question arises, who is doing this task at that time? Because we are not controlling that manually. Who is responsible for that? So basically, the microcontrollers are responsible for doing such kind of tasks. Okay, and it works very fast. Right now in the Arduino, the Atmel 328P, I think, yeah, a microcontroller is used, and the speed of this microcontroller is something like 16 megahertz. So it can works very fast as we can do. As we can do not means it can work faster than us. Okay, and it's a programmable device. Whatever you want to do, like whatever kind of task you want to perform. Okay, the tasks are infinite. Whatever project you want to build, you can easily build on it and program by yourself. And also it's an open source device. Do you know what the open source means? Basically, the Arduino, the company basic which is originated in Italy, I guess. Yeah. So what they did, they will make it open source. Means anyone who is a developer and had great knowledge in the field of microcontroller and the electronics, so they can make their own boards. They are not going to send them copyright strike and all. It's a open source. You can do whatever changes you want. Okay, so that is the core reason because of the popularity of this particular board, because it's an open source. In the end of session, I will show you some different boards which present over here, and you will see that there are lots of company. What they did, they took the Arduino and they place their own microcontroller like ESP and other, and they make something like that Arduino with the extra functions. So that is the very good point, that it is fully uh, open source and used in various applications, as you know, and the different types of boards are there. Yeah, the company makes a different kinds of board like Arduino Nano, Arduino Uno, and Arduino Mega and all these. And it's a beginner friendly. Yeah, because when initially when you start learning about the microcontrollers and all, so previous time the only one way you have, either you will code in the assembly, otherwise use the embedded C. Embedded C and assembly is a kind of thing that which cannot actually any beginner cannot deal easily, because it contains a lots of knowledge about the programming, and like hardware abstraction layers. You have to know about the pin diagram and all. So it's a very complicated. So at initial level, embedded C and the other languages like robust is language is quite popular at that time. So these languages basically very hard to program for the any beginner and the developer. So here the solution comes, is name as Arduino. Okay, so need of Arduino. Okay, now the second question arises, why why we need a microcontroller. As I previously told you, who is gonna to turn on or off that particular light when a man enters? It's a question. See, we cannot do, right now we are surrounded with many and many electronics items and all. And we cannot operate it manually in each and every electronics items. And even we are not more efficient such that as other microcontrollers and uh, other processors can do. We are not efficient in such manner. So that's why we actually need a microcontroller. Yeah, it's automatic. But the mean of automatic here? Automatic means you give them a particular task, like in your home, basically you see oven, right? You just place a alarm, like set an alarm for the 30 minutes. So it's basically what it did, cook the food for the 30 minutes, and then after the 30 minutes it stopped, right? So like that, it if anyone sees this particular task, so it is kind of automatic thing, na? You once you told in the form of input, right? Okay, the 30 minutes is the time, and then turn it off. Okay, so it will actually manage these things, and uh, yeah, it will manage these things and all. Okay, so what's the real life examples and all about microcontrollers, right? So like smart fridges, how we will discuss about it, like how the smart fridge, like normal fridge also, not a smart fridge, but yeah, smart fridge has some more functionalities. So we can say, and automatic street light. You saw in your city that when sun sets, the light started in the light started to glow, right? So these are the examples of microcontrollers and all. Smart smoke detectors. Some of you might have seen, like in the cinema and in the trains, they are kind of smoke detectors, which is something like that. Yeah, something like that are present when anybody starts smoking, right? And this particular device get activated and make a sound, something like that. It means alert the other people. So, and smart air conditioners and washing machines and drones. So these are the basically real life examples where the microcontrollers are basically directly playing an important role in our life and our surroundings and all. Okay. So now we are uh, quite closer about learned some deep about the microcontrollers. Now I will tell you how the microcontroller basically perform a task. Before performing a task, you have to know that what kind of things, what kind of task would you want to perform from the microcontroller. So let's take an example of the air conditioner. Okay. What is the task? Basically, the air conditioner, what it did, it maintained the room's temperature. So how the microcontrollers comes in the pictures and maintain these things? See, the first thing is firstly, AC will see that what's the temperature of your room, right? For example, if you said, okay, it's 25 degree and maintain the temperature 25 degree. There's a kind of microcontroller was embedded in the particular air conditioner and air conditioner, and what it did, it take data from the sensor. Some of them might have seen that there's a sensor was present in the upper side, yeah, at this point of the air conditioner. So what it did, it firstly it sends the outer environment data, like how much temperature in the environment it has. Like if you set to 25 and outer environment is 40 degree, so it sends, okay, now the outer environment temperature is 40 degree, it sends to the microcontroller. Now microcontroller here will decide. What decide? Firstly, it will get an input from the user, like at what temperature you have to maintain your room. If it's sorry, if it is 25 degree, so it will compare. Firstly, now think, it will firstly compare the temperature is higher or lower. It is simple that the temperature is higher than the set temperature. So what it did, it activates basically the other compressors and all, and it activates the compressors and increase their speed and controls the fans also. Okay, and start cooling until and unless when the temperature rises to the falls to the 25 degree. As temperature falls to a 25 degree, again temperature sensors sense this particular data. Basically this process happens in the several times of in a second. Okay, so it again sends the data. Okay, now then see, it is quite closer to the 25 or the 25. Then what the microcontroller did, it slows down the compressors and the compressors and the free and the fans and all. Then if something like okay, now if it is door is open, the kind of things that happen, so maybe the temperatures again starting rising. So it will again see. Okay, now the temperature is something like 28. Now again do it the same step. So basically, what a microcontroller did, do a perform tasks in loop wise. Okay. When you program the microcontroller, you will see there's a inside the programming you will get the two parts. Basically, one is the setup and the one is the loop. So setup, what it did, once you define the parameters there, and the loop is the main program part where you will basically uh, put your code, which actually moves around it, means uh, moves it several times. Okay, and compare it with the temperature. Then these cycle will works on. So that with the help of the microcontrollers, we can manage the temperatures and all. Okay, now the one more interesting thing, I think many of you knows about the drones, and many of you very interested in the drone technologies and all. So what is the role of microcontroller in particular here? See, what is a drone basically? Drone is a perfect example for the learning about the microcontroller. Why? Because see, inside the drones there's a kind of sensors are there, like GPS sensor. So here the main thing which is the microcontroller, which manage the all particular activities. I will tell you the how the in what way the microcontrollers basically manage these things. Basically, first what microcontroller did, takes the sensors, initially set up the sensors and all, and see that what kind of data we are getting or not. So after set up the each and every sensor, it start sensing the data, means reading the data which is coming from the users. Means you know that if you fly a drone, you have a joystick, okay, and you just press a throttle. So when you press the throttle, so it will send a signal in the form of 0 to 1024, 0 in the range of 0 to 1024 data in the form of that. Means if you are uh, moving your throttle 20%, so data will be 200, okay, and if you are moving your throttle half, so data will be something like 500, 512, like, okay. So on the basis of data, what it did, it starts activating the all others motors, okay. It's start activating the all others motors. And also it the one more part, what is one more part is a reading sensor data, because the flying of the drone is a quite not a quite, it's a very complicated thing. This term comes is known as flight controller board, okay. So basically what the work of the flight controller board, when a drone starts flying, so in the air, maybe sometimes happens like some of the motors will start working slow, and what the other starts faster. So what happens, let me show again in a minute. Yeah, see, if it is a drone, see, and there's a motor like M1, M2, and M3, and M4, okay. So what happens if this M1 motor start some high speed? So what happens? So if it is start moving some high speed, so it will generate thrust in this direction more as compared to this one. So overall drone will be tilt in this direction. See, so these things also be managed. Otherwise, your drone cannot be stably flies, right? So what the as the drone started tilting in this direction, there's an accelerometer, or like a gyroscope sensor. Okay, gyroscope sensor is there, which gives the information to the microcontrollers. Okay, what's the information it provides? Your drone is tilting in this direction, so you need to slow down this motor one speed. Sorry. So as it's getting this data, automatically it will generate a signal, or generate a signal for the slowing down this particular speed. So then after just slow down, and then the overall drone comes in a balanced position. Now what happens when you state say forward and backward, like this is your transmitter, and this is your joystick first, and this is your second. For example, if you want to if you want to send it the forward direction, what happens? Basically, when you send the direct data for the forward direction, microcontroller read particular data, okay, and microcontroller knows that which motor corresponding for the which direction, which these things you have to provide when you are coding the microcontroller, like which motor is corresponding for the which direction and all. So like this the, okay, if this is the forward direction, okay. So what you need to do? You need to thrust. You need to more thrust in this and this motor, 2 and 3, because when it provide more thrust, so overall force in this direction will be increased. If the force in this direction will be increased, so automatically drone start going in this forward direction. So as it gets the data from the your transmitter, from the transmitter, it sends a signal to the flight controller, and the flight controller will start sending the data like move this motor very fastly. Then overall your drone actually goes forward. These are the core uh, idea of the microcontrollers. Okay, 1 minute. Moving back 1 minute. Sure. Okay, so I hope you will clear about this point and maybe familiar with about the uses of microcontrollers. So, guys, are you getting what I'm wanted to say? Just asking for your responses. Anyone can tell me, are you getting it or not? Just on your
Yes,
mic.
sir, everything is clear.
Okay, okay, okay.
Everything is clear.
So, okay. So
Yes,
basically,
very clear.
okay, okay, okay. Great, great, great. Now we will start about
Everything is clear.
components of the. Okay, 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 okay. Great, great. Now we will start about learning about the components of the microcontroller. Okay, what kinds of component are used in that particular board and all. Basically, what for being a developer, what things we have to know before programming a microcontroller, before making the projects and all. So I will urge to you that if it is possible for you, so make a note, right? Take a pen copy and all, so it would be helpful for you, right? Because the end of the day, end of this workshop, you are making your own projects. I'm trying like we will provide you some projects that you basically you made, okay? And so try to keep a pen and copy if it is required for you. Otherwise, leave it, okay? So now we will start. The first thing is the central processing unit. You know that in the PC, like computer, there's a kind of thing, central processing unit. The same which central processing unit in the PC, which deals basically for the like no, sorry, sorry, which basically deals about the logic parts and calculations parts and all, right? Arithmetic and logic unit and all. So the same thing. There's the same thing happens in the microcontrollers also, because it is nevertheless it is a small kind of computer, because it is computing, doing performing such a task. So the same for the performing the task, doing some operations, like when you program, there's a kind of operations are there, like might have adding operations, like if you want to add something, okay, and this is numerous number of things are there. So handling with these things, we have a central processing unit on the Arduino. This chip you can see, right? I think you might have seen this chip. This is Atmel 328P, yeah, 328P series. So this basically chip is responsible for the central processing unit of that particular microcontroller. Basically, central processing unit also executes the program, that program in the form of like a task, that what task you provide them, right? And it operates on the clock speed of 16 megahertz. So 16 megahertz, what is the mean of 16 megahertz? Anyone can tell me? Okay.
Operating speed of that microcontroller.
Yeah. Okay. I will tell you.
Frequency
16
of
megahertz
microcontroller.
means. Yeah. So okay, I will tell you. I'm telling. Like let me remove it. Now. Just a second. See, the meaning of the 16 megahertz means 16 into 10 raised to the power 6. Mega means 10 raised to the power 6. Basically, it means that it has a 16 million clock cycles in a second. If Arduino is working their full efficiency means basically we are not use the 16 megahertz clock directly. We use different techniques like clocking and all. So 16, if you are using your microcontroller at a fully potential, so it can proceed 16 million instruction in 1 second. You can think it can proceed this. Also, you can say if Arduino takes, I'm just giving you example. It's not very accurate, but yeah, I'm just giving you example. Right? If Arduino takes one particular task in a one clock cycle, okay, then it can perform 16 million tasks in a 1 second. See, but the thing is, Arduino is not always working on their full efficiency, and depend upon the task, that how big task is, like if how much time it would take, and so these factors also matters. So basically, the 16 megahertz corresponds if there is a one clock cycle, and in a second you have a 16 million tasks. Okay, so this is the basically meant for the clock cycling. Okay, now what's the memory of the Arduino and all? Arduino Uno has 32 KB of the flash memory. What is the flash memory? Flash memory basically the memory where you store there your program. Basically, you write a code. No? If you want to program a microcontroller and do particular task and all, so what you have to do, you have to program your entire system. So the programming which you may happens like in our workshop, we are basically focusing upon Arduino IDE. So you will when you basically program the uh, Arduino, so you will have to write the code and all. So the maximum size of the code it can bear is the 32 KB. Okay. So flash memory is the place where your actual code. Basically, what IDE did, you wrote a program, then compiler makes it system readable form. Okay, then the second process what happens, it's generate a machine code, and that particular machine code goes in the your microcontroller. So the maximum size of that particular machine code, which is indirectly where we can say it's a program, is a 32 KB. Might have you very surprised that 32 KB is a very less size, right? Because nowadays we are dealing with 16 GB of RAM, 250, 1 TB of storage. So 32 KB is quite low, but no, it's not low. Even whatever program we want to do, you can easily make that particular amount of memory. I think 32 KB is enough for the like 10,000 to 20,000 lines of code easily. Even I personally tried some codes. I personally tried to run some programs before 1 month ago. I'm just working on my some larger program. So the overall lines of the code is 8,000. Actually, I'm working on some machine learning topics and all. So overall size of that particular code is 8,000 line, and it is easily manageable by the Arduino. So don't think that 32 KB is the less size and all. And the Arduino Uno has a 2 KB of SRAM. SRAM is a static RAM. Basically, what happens in your program, you might have uh, chances like you have to declare some variables. Variables is a kind of in the programming. Those who are familiar with the programming, they know what is the variable. Like the variable basically object like thing that which particular hold a particular data. Okay, so you have to make your variables in your program it quite often, right? So these variables and other things like program related things like function calls, stack of the program, like stack memory and heap memory. I hope you know about it. So these things are basically comes under the SRAM. So static RAM basically 2 KB of RAM, just like in our laptop that 512 GB of the SSD. So it is 32 KB of the flash memory, and 2 KB of SRAM is our 16 GB of RAM. It is something like that. And the Arduino, include 1 KB of EEPROM. EEPROM means electrically erasable programmable read-only memory. Means it's a non-volatile memory. Basically, sometimes what happens, like when you use a microcontroller, when the power supply is cut off, that whatever data it has, for example, you take an input from the data from the user and is stored in a variable, and if the power is gone, then your data will be deleted. Now you don't have option to take again data. So if you are dealing such kind of data, that will still remain after power cutting and the supply and all. So at that time you will save that particular data into EEPROM. So EEPROM is a kind of memory where you basically write that particular data which is important for you, like you don't want to lost that particular data, and also it's a non-volatile memory. It's a very less, it's a 1 KB I think. Other microcontrollers have some more, but yeah, in Arduino it's very less. Okay, now we will move forward about the input and output ports of the Arduino. So overall thing, this is the boring things actually. Now the things which is actually interesting now coming over here. What's the input output? How we will communicate with the Arduino with the other involvement and all, right? So input and output port. Basically, you see there's a lots of ports there, right? There's a 0, 1, 2, 3, 4, so till 13, and A1, A2, A5, and all. And there's some power supply ports, the VCC. So you can communicate with the outer world, like you can add a sensor, add a LED, control actuators with the help of these pins. So these are basically the input and output pins. Okay, everything related to the Arduino will be handled over here. This is the core heart of that particular board. So this is the input and output pins. We will discuss about it later in the great detailed way. And this analog pins also, and the PWM pins. I will discuss about what's the PWM and all. So let's see. So now what the onboard components of the Arduino? See, this is the analog input pins. See, one thing I will clear you. What's the analog and the digital? Okay. See, for the digital, in your childhood, I think you used a LED. Just take. Drawing is very bad. Sorry. Like you take an LED bulb, and just connect with a switch. This is the switch symbol in the electrical engineering. So, and this is basically battery. This is a positive point, and this is a negative point. Okay. Now whenever you press the switch, okay, the bulb start glowing, and whenever you close the switch, bulb stops, right? So basically, you can see there's only two modes, either only two states, only either on, either off, right? So only two signals are there. We in the electronics, we basically on signal which we basically represent it as one, and off signal is represented as the zero. Okay. So now in the digital signals, you are dealing with the only those two, like on and off. On in the Arduino like microcontroller, for the on signal, just it provides at that particular pin to the 5-volt output. Okay. If you want to say that, okay, I will generate, like I will show you, I will generate on this 0 pin high signal. So what I will do, I will read only digital write high and a particular pin here. So what it did, it will just generate a 5-volt over here, this pin. Okay. So digital pins are those who has only two logics, high, either low, only two. High will shows are the 0 volt, sorry, a 5-volt, and the low will be 0 volt. Okay, I think it would be clear. And the second kind of input basically Arduino will take is the analog input. What is the analog input, sir? Okay, I will tell you. Like, see, this has only two input and outputs, like 0 and 5 volt. What happens if any sensors we have, and it is providing 3.3 volt, like there's a temperature sensor. I will tell you. Okay, and a temperature sensor, for example, at the 10 degree, it provide a 10, it provide like at the 10 degree it provide, for example, 1 volt. At 20 degree it provide a signal of 2 volt, and the 30 degree it provides a signal upon 3 volt, and so on. And the 15 degree it provides 5 volt. So what happens when you connect with the digital pin, right? So 1 volt, 5 volt will be okay. It will easily understand. Okay, now 5 volt it will easily understand that, okay, 50-degree temperature. Then what about the other, like 4 volt? It might have been 4.3 volt. It might have been 4.4 volt. So these are also the signals. Basically, in the electronics and the sensors, everything, every signal has to be in the form of voltages and the currents. So you have to deal with the voltages and current with the electronics in the electronics. So every signal in the form of voltages and current. So what you have to do? Your sensor will not work with the digital pins. So for the sorting this particular issue, this a kind of thing the comes with an analog input, because the values are right, you changing, like analog you have might have seen the sine wave like that. Okay, the infinite value. So at for the handling this situation, we have analog pins which can take multiple levels of input, between the 0 to 5 volt. Okay, 0 to 5 volt, they will split it in the range of quite zero point 0.3 millivolt, if I'm not wrong. uh, and split it, and it will take the input in the range of particular. If you are providing 2.33 volt, it will easily detect, okay, doesn't tell me, okay, it's a 2.33 volt, and it will generate, basically Arduino will generate a corresponding number to that particular thing. Like basically what it did, firstly it will receive that 0 to 5 volt signal, then it will proceed and provide 0 to convert it as in the range of 0 to 1024. Okay, 1024, basically when you're dealing when you're working with the fading experiment and all, then you will very well uh, you will be very well known about these terms. Okay, so I hope it is clear, like what is the Arduino, analog inputs and all. This is a kind of a power supply section. See, and on board you will see there's a USB TTL converter. What is the USB TTL converter? See, USB to TTL converter is like a thing. Basically, when you program your Arduino with the help of a computer, what happens? Computer uses the USB to communicate with the Arduino, but Arduino cannot easily understand the USB. So there's a kind of driver-like thing comes. There's a device which is placed on that particular board, this particular development board. So this basically change the USB signal to the TTL form, means it can easily understand and communicate with the USB port. And there's a 5 volt regulator, LM358, basically, sorry, LM7805, yeah, LM358 is that. So LM7805 is the 5 volt regulator, which actually sometimes you might have seen that, okay, firstly you program it, and now you are start working on your projects and all. So everywhere you cannot connect with your laptop or the providing the supply, so you will just connect a DC jack over here, and it will send this voltage to this power supply to this regulator, because it will regulate, you can provide the supply in the range of 6 to 12 volts, any kind of battery and whatever you want. So basically it just take this particular supply and convert it to, like not a convert it, regulate it on the particular 5 volt. Okay, then need to provide this 5 volt to this particular Atmel IC, because this IC is working on the 5 volt, even some more microcontrollers are there in the market, like ESP series microcontroller. So ESP series microcontrollers have some different property, like they working on the 3.3 volt and all. And this Atmel series, most of the Atmel series microcontrollers and some of the ARM series microcontrollers, ARM Cortex M0 series and all, they basically works on the 5 words. So you have to see about these things about the data sheet and all. So, but you don't have to take any worries about it, because the development boards which the company makes, they basically do such kind of work by their own hands. You don't have to need any do anything else. Okay, so this is the basically DC jack where you have to put your supply and all, and the fuse and etc. things are there. This is a clock that I am telling you is a crystal, 16 megahertz crystal. Okay, this which basically provide the clock signal and all. So communication interfaces. The communication interfaces was the communication interfaces. Basically, okay, just a minute. So, guys, it is clear to you, all of you, like you are connecting with me or not? Okay, just, I'm just waiting for your
Sir,
response. I'm
USB
waiting in the
TTS.
like.
Can you repeat it again?
Sorry,
USB TTS.
your voice is.
Sir, please repeat USB TTS.
Sorry, I cannot hear your voice is not clear. Can you anyone other can tell me?
Sir, USB
I'm
TTS.
waiting.
Can you repeat it again?
I'm waiting for your response, please.
He is asking to explain the USB to TTL again.
Okay, okay. USB to TTL. Okay, sure, sure, sure.
Please ask your question in last.
Uh, okay, no problem. Well, I will ask. What is the USB to TTL? Basically, TTL and CMOS, there's a two kind of logic levels. When you learn about the deeper in the electronic systems and the electronics, you will see the two kinds of interfaces are there. Logic systems are there. Like one is the TTL and the second one is the USB. What is the TTL works on the some current detection mode. It have some voltage sensitive and a current sensitive, because these terms are quite heavy over here, because these are very hard. It's a very hardcore electronics terms. So I will just trying to do it. So this microcontroller basically working on the architecture of the Atmel series microcontroller based on the TTL architecture. Okay, so current level sensitive architecture, TTL. So and the USB communication basically use the only two things. Like when you see the USB port, there's a 4 points are there. Like first two part are for the supply plus minus, and this then two for the communication line. But a TTL, but here TTL signal, when it basically goes in the microcontroller, it have some other kind of architecture. So we need a kind of driver, kind of a bridge over here, which can easily communicate, or basically which will provide a common base to put your program or communicate with the Arduino and PC easily with the help of this USB to TTL converter IC. Basically, I will tell you what actually works. I remembered before sometimes I'm working on a particular project. So what happens? I just upload. Firstly, I upload my code and all, and testing and all. And when I'm sending the data from the serial monitor, basically serial monitor is a computer monitor where you send the data. What happens is data isn't everything is working well. Microcontroller is working well, but data is not getting inserted in that particular microcontroller. I'm very surprised at why it is happens and all. And after that, I will research, and after that, I will find that this IC, particular USB TTL converter IC, has been damaged. So, if this IC will be damaged, your communication line will be take off. So, communication with the serial and other things, it basically managed by this particular USB to TTL communicator IC. Okay. So now we will move forward and all. Now the communication interfaces on the Arduino, like USB interfaces. Like USB, as I know that when you connect with the Arduino with your PC, like with the help of USB, you can send data from there and all. So basically, when you connect it from a PC, the serial communication comes. On the Arduino IDE software, you will find there's a kind of serial communication. The two software are there. Two, not a software, is a kind of integrated part of that particular IDE. Serial monitor and the serial plotter. See what if you want to communicate, want to send the data, want to read the data, if anything would you want to do, you can use that particular serial communication, serial plotter on the serial monitor, and serial for the serial communication. Like serial communication is a wide range of communication. It is also known as UART, Universal Asynchronous Receiver and Transmitter. Okay. See, there's a two pins are there, 0 and 1. See, okay, like when I'm telling you about this temperature sensor, right? So temperature sensor basically sends the data in the with the help of the serial communication. Yeah, there's a, if you have a temperature sensor, we will show you in the later workshops. I will also demonstrate these things and all. So temperature sensor basically use the serial communication. So basically you are seeing the 0 and pin where the TX and RX is written, right? TX and RX. So these pin basically responsible for the serial communication, and it's a very kind of easy protocol. Like only you have to do only two. You have to connect only two connection, two wires, and provide like ground and VCC supply and start communicating. You don't have like massive wirings and all, only two wires communication. The same thing is the I2C, but yeah, the speed of the communication is some kbs. I think if I'm not wrong, 10 to 100 kbs. The speed is low, but yeah, you can easily communicate. Sorry, I2C communication is the some advanced version because it has some 100 kbps to 400 kbps. Okay, so it uses on the two pins, HDA and SCL. HDA we say HDA pin is basically on the Arduino's A4 and SCL is A5. Basically, SDA means serial data line. Okay, data line basically when they're transmitting the data. So there's a server. I will let me open again. Okay. Oh, okay. So see, if it is a device which basically transmit and it is your Arduino microcontroller, and it is your sensor. If you want to connect your sensor with the help of SDA communication, you just need to connect two wires. Okay, and the VCC and ground are also there because common ground referencing. This is the SDA, and the second one is the SCL. Basically, what is the mean of SDA and SCL? It's a quite it's a deep topic as well. We are not going to such kind of deeper way, but I will tell you what is the HDA and what is the SCL. So basically, when a sensor says, okay, I want to send the data to the microcontroller. So what it did, it just first send a signal by sending this particular line low. Yeah, send a data, send this particular line to me 0 volt. Microcontroller sends, okay, there's a zero signal is comes. That means now the data is going to come from the this sensor. As it high, it will provide a clock cycle. Clock cycle, like a square wave. Then it started the square wave. So after starting the square wave, what happens? It okay, this line is corresponding for the okay microcontroller. Ready now, the data is going to come for you. After this square wave start generating over there. At the end of this particular rising edge, see, there's a rising edge. Okay. So at the rising edge, for example, it will sending a data in, like it want to send a 3 volt data. Okay? So what is the corresponding binary code for the 3 is the 0, 0, 1, 1. Okay, 0, 0, 1, 1. If want to send the 3 volt means the 30 degree temperature. Okay, like So it will send, if it is a 8-bit architecture, mostly they are in 8-bit architecture, so it will send a data in the form of 000, 4 zeros and 001. Okay, this is the particular binary code of this 3-volt, right? So it will send the data. Firstly, it will send this LSB 1. When send it, that particular it send a data 1 at the high rising edge, it will detect and stored in a memory. Okay, first data is 1. Then wait for the next cycle. Now next cycle is there, right? It will see again it's a 1 volt. Okay, so a microcontroller at that particular, sorry, SDA sensor at that particular time, it will also send it to 1 volt. Okay, then it will save it 1 volt, and again in the this particular cycle, what it will send this particular line to 0 volt. Okay, at the 0 volt, what is sense is the 0. Then again for the further 8647 skills, that's 0. Now microcontrollers just just communicate with the outer world and save this particular data. They communicate with the help of SDA and SCL. They have a data. Now microcontroller read that particular thing and calculate the what is the value, that what is the corresponding is 1001. That means it is the 30 degrees Celsius the temperature is. Okay. So like that, you might, the communications happens. Okay. Now it's I2C communication. I2C communication, the inter-integrated communication is, and ISPI XPI is basically some yeah. ISPI is a quite advanced communication. Like in the SPI communication, the 4 wires is required. MOSI, MISO, MS, SCK, and SS. SS means a signal line, select signal, and SCK means select clock line, and MISO is a master input, slave output, and master output, slave input. Basically, with when you communicate using the SPI communication, you can simultaneously send the data and read data as well. Like see in the SDA, like this in the SDA communication, you can see when only one data line is there, means you can either send the data, or if it is the first one is sending the data, you cannot send again from this side, right? So this make a cause like you are not able to send and receive data simultaneously. So SDA SCL here comes, it has multiple numbers of lines. So not even having the multiple numbers of lines, 4 wires is required, like MOSI, MISO. So it can communicate in the 2 ways. Like if we are getting in the more deeper way, so our workshop will be quite advanced. So we are not going that particular way. So now we will start about the detailed pin configuration of that particular Arduino board. Okay. So Arduino board, in the Arduino board, basically you are seeing the lots of kind of pins. When you open the Arduino site and see the data sheet, so how you are going to read this particular data sheet, what the data sheet want to say to you, how you will read. So there's a kind of pins are there, what is the pin, and we will discuss it. So let's see about the right side of the pin. Okay, so it is the schematic diagram on that particular side, detailed view. See, it is the right side pins. Okay, see, this 0 and 1 pin is there. It is first, it is denoted as 1 and the 0. From the 0 to 13, this number is provided by the Arduino software. Okay, this is the not the number of which microcontroller deals. Microcontrollers even didn't know what the number is it. For the making this making the things quite easily understandable for the new beginners, the Arduino company, what it is, it named that particular pins. But in the originally, what the microcontroller known about these pins is that these PD0, PD1, PD2, these are the resistors. Basically, resistors are the corresponding for the each and every pin. Okay, so these are the number of the registers, but you do, if you are beginner, you are not need to learn about the number system and the register shifting and all. You just for the simplicity, and you just need this particular lines, this particular things like 0 to 1, 0 to 13. So see, 0 and 1 are the TX and RX. So TX and RX means you can communicate using the serial communication UART, like as we told you. So any UART signal, every sorry, not a signal, it's a sensor. Any UART sensor you are using, so every sensors TX and RX will connected over here. Okay, you cannot use any of that pin because every pin has their own perspective. And if you are using the UART signal, so you can use it. And you can see there's a kind of sine wave like thing, like arrow like here, presented in some particular pins like 3, 5, 6, 9, 12, and 11 and all, right? So what is the mean of that particular sign? And you will also say that the thing is written as a PWM. What is the mean of PWM? Basically, PWM is a kind of technology, is the kind of hierarchy which used by microcontrollers to generate an analog like signal. It's not an analog signal, but like an analog signal. Like I will tell you what's the PWM. See, if you want to, and digital pins can generate either high means 0 volt, either low means or sorry, either high means 5 volt, either low means 0 volt, right? So if you want to say that we want to generate something like 2.5 volt, so what we did, so here we cannot generate directly because 2.5 volt generating is directly with the help of microcontroller like Arduino and what is not possible. We use a technique which is called a pulse width modulation. What is the technique? See, if we either high, either low, okay. So what we did, we make this signal high. Just a minute. We make this signal high for 1 second, and this 1 second, then 1 second. 1 second is a very large. I'm just giving you an example. 1 second and 1 second, half, low and high. Okay, see, if you do make a square wave like that, yeah, which can Arduino can make this square wave very easily, just high and low and all. So see, what is the average of this particular wave? See, if it is something like high and off, high and on, high and on, so it is if you're taking the average, so it will be something like at that middle point. Na? It is working on the 50% of that duty cycle. So when you measure with is the V average in the engineering in the electrical engineering terms, you know V average, V RMS, V peak to peak, and the V average means the average voltage. If you calculate the average voltage, so average voltage will be 2.5. So by this technique, we can get the 2.5 volt of the average voltage, right? So it is not a 2.5 volt because the 2.5 volt is something like that, but it is the way that we can generate. Okay, it is not a pure 2.5 volt. Again, it's the average 2.5 volt. Pure 2.5 volt is something like that. You are generating a signal like 2.5 volt. It is different. So PWM is a kind of technology which, with the help of this, we can generate this kind of average signals from the 0 to 2.5 volt. PWM is also used for used for the controlling the speed of motors. In the further workshop, we will see how the PWM acts for the if you want like glow a LED and dim their brightness, and also these PWM signals are works. So in the Arduino, not all pins are basically able to perform like not a perform like provide these PWM signals. Only 5 pins are there: 0, 1, 2, 3, 4, 5. Not a 6 pins are there, which can basically provide a PWM signal. So if you are using with that particular sensors and actuators that basically works on the PWM signal, so you just need to connect only these pins. Okay, you don't have to access to like connect anyone else there. Then the project will not working. See, I told you about the serial communications and all. This is the SPI communication. If you are using a sensor like which uses the SPI communication, MOSI. This is a pins HDSCL. So you will use that particular pin. See, like 13 number is for SCK pin, 14 is the MOSI, and SCSCL. Okay. And many have you seen there's a kind of things are written as a PC init 5, PC init 4, and 3. What is it? PC init, it is a macro. Macro, those who are familiar with the programming, that they might have know about the macro. But it is a quite embedded C and assembly language things, because you don't have any work in the Arduino like Arduino IDE software like PC. It is a core hierarchy things like AVR architectures. Basically, Arduino follows the AVR architectures that. In the AVR architectures, they have written that particular code at particular these pins like PC init 5. That P stand for port, C stand for C. That means the port C of that particular uh, when the engineers write the architecture of that particular microcontroller. So what they did, they designed a port particular for the performing that particular task. So they assign that port and all. So port is C and init 5 means the address of that particular port, which is corresponding for this 13 pin. Yeah, but these things and OSC 2AB and all these things are basically for those guys who are going very deeper in the era of this particular microcontroller and all. So you don't need to think about it. You just think about these pins and what have PWM, where I have to connect analog pins and all. And right side, sorry, in the left side, you will see the 5 pins is the analog input pins and all. See, analog input pins like if you are dealing with the analog data. Okay, analog data, as I told you now, data is a 2.3 volt, 4.4 volt. So where you provide the data as an input. So these are the pins. If you are sending an analog input, with the form of voltage, so you can use only these pins. You are not to connect that particular analog input to the digital pins. It may be damage your microcontroller because they are not designed for that particular task. This also has a ADC. It is known as a ADC, means analog to digital converter. Basically, what your overall microcontroller only knows about the zeros and ones language, means a binary language. It don't know 5, 4, 6. So ADC, what it did, ADC basically take that particular data which is coming like 3.3 and all, and just to make to corresponding or just to make the corresponding binary code, like as I previously told you now that sending 3 volt is a 4 zeros and a 0 1 0 0 1 1. So ADC just do like some like the same work. Input, then make that thing in the corresponding like that, and forward to one. Okay, so there's a 5 ADC, not a 5, I think 6 is there. No, 5, 5. Okay. So totally 5 ADCs are 5, not 6 actually, because it is starting from the 0 now, so totally 6 ADCs is there. That's right. So there's a 6 ADC are there. You can easily communicate with that and send data and all. And the SDS, there's a SDSCL line. Okay, you can also connect the SDSCL point there also. Okay, now the coming of the type of Arduino system in the market is lots of microcontrollers. As per your size and as per your requirement, you can choose the microcontrollers. What the your requirement? Like first, you know that Arduino Nano. What is the Arduino Nano? Arduino Nano is a very small and tiny version of that particular. I will show you each and every microcontroller physically over here after completing this overall things. Like it uses the Atmega 323328, the same microprocessor it has. See the SMD version of it, and the same number of pins, the 6 PWMs and all analog inputs that only 8 pins, right? And 32 KB of the flash memory and 1 KB of from like Arduino Pro Mini. It's a very smaller and tinier version when you are dealing with the projects when where size is very limited. You are not able to free like For example, if you are developing a smart watch, like smart fitness band like thing, so that at that time you have to fit the each and every component and the microcontroller and all in a small, like 20 by 20 centimeters area, like so here at that particular project you can use this Arduino Pro Mini, like Arduino Mega. See, Arduino Mega is a kind of advanced, not advanced, but yeah, it's a father of that particular board. So it's a 54 pins, one of my favorite board is. My first preference if I'm working with the projects and all, I will basically use this particular Mega. Basically, it has 54 pins, 15 different PWM pins. You don't need, you can connect the 15 different kind of, like say if you are using the servos and all, making a robot dog, for example. So 12 servos it will required to control the robot dog. So it will easily connect with that particular server and easily manage. See, the flash memory is also 256 KB. Here we are only getting 32 GB, KB, and 8 KB of SRAM, 4 KB EEPROM. So everything is more than Arduino Nano and Premium Pro Mini. Okay, and the Arduino Leonardo in the India is not a quite popular. In the other countries, the Arduino Leonardo is a very popular. I saw Arduino Leonardo before some time. Right now I don't have, but yeah, this is some kind of code which basically use Atmega 32U4 microprocessor, microcontroller, and 20 PWM pins and all. This is some kind of things out there. See, this Arduino Mega. Some I also set a pin diagram and all. See, there's from the 0 to 13, there's always the PWM pins and all. See, you don't have to worry about 4 and 6 only. Maximum amount of pins are there. You can connect only totally 15, 14 servers and all. For the serial communication, see, there is a serial port 0, serial port 2, 3, 1. There are 4 different serial ports. You can communicate with the sensors and all with the 4 different sensors at the same time, right? And there's lots of SDA and SCL pins and also. And the 15 different, 54 different input and output pins. And the analog input pins are very much like 16 analog input pins and the power supply pins and all. See, so this is the Arduino Mega, and Arduino Nano, same the things. This is the Arduino Nano, like 31 pins are there. The pins I think in the Arduino Nano and Arduino Uno is quite same, but yeah, the size of Arduino Nano is very less. Like it is equivalence with your finger. It will easily, you can easily put at your finger. It is very small, tiny size. So in the Arduino Nano, there's a lots of in there. Okay, one more thing I will clear. When you read the data sheet of the any Arduino, you will see there is a kind of this sine wave life structure. Basically, it indicates that this pin particular supports the PWM output. Okay, that means 15, 14, and 13 number pins can easily support the PWM pins. Same thing over here, like 9 and 10 easily supports, and one number is supports. And these things are you basically familiar with that and all. Okay, in the market, the other kind of microcontrollers are also with here, like ESP32. What is the ESP32? ESP, you might have known about it. ESP32 basically is very popular. It has a dual core processor. Basically, dual core means it can do 2 tasks simultaneously. Okay, and memory also it has 520 KB. Like it's some more than Arduino, and the external flash memory, the 4 MB it supports, and 32 and the 16 PWM pins. See, and the built-in main thing is built-in Wi-Fi and Bluetooth, so you can connect it with your Wi-Fi also. Bluetooth, you can directly transmit the signals and all via the Bluetooth and all. So in the Arduino and the other microcontrollers, Bluetooth and Wi-Fi. If you want to connect with the Bluetooth, so you have to add some other Bluetooth modules and Wi-Fi module sensors for the connecting with the Bluetooth and all. But in the case of ESP32, you don't have to need any worry about that. ESP32 has the inbuilt Bluetooth and Wi-Fi services. Okay, and like ESP826 is the smaller version of it, like Tensilica L1066. I'm not wrong. Yeah, Tensilica L1066 is the processor which basically used in the ESP32. It has 17 different pins and input output pins and 9 PW and it's 80 KB of RAM and 4 KB of MB of flash memory and built-in Wi-Fi. In the ESP32 8266, what the thing is, Bluetooth is not available. One drawback is there, that the Bluetooth, if you want to connect with the Bluetooth, so here you will add an external module and all, device and all, so that will help you to connect the Bluetooth. Also, Raspberry Pi also uh, introduced their microcontrollers for the not a microcontroller, it's a kind of development course for the electronic enthusiastic people. It's like Raspberry Pi Pico, which basically dual core. Dual core, I will explain about the course. So basically, you will get more idea. See, it is a microcontroller, okay, and you say that do a task one. Like task one is like turn on and off an LED in every 10 milliseconds. Okay, 10 milliseconds. And s- same thing you say, 1 minute. Same thing you say that turn on and off other LED2 at same time, at same 10 milliseconds. So what happens? Basically, see, the CPU of the Arduino follow these instructions. First instruction is turn off this LED. Okay, then off. Then after 10 seconds, it off. This is also a command there. What happens about this? So Arduino will not able to do this particular task because he is stucking on that particular task. How it will move at that particular point? So here comes the dual core system. Basically, first core will handle this particular task. Okay, on off attachment 10 milliseconds, and you can design the second core also. You can activate the second core for doing this task. So you can do two tasks simultaneously with the help of these microcontrollers. Only ESP32 and ESP32 and one more is Raspberry Pi Pico. Cortex series, ARM Cortex M0 and M01 to M7. These are the basically processors are used in the Raspberry Pi Pico. That allows you the dual core work. Okay. So also there's a STM32 microcontrollers. So STM32 makes a wide range of microcontrollers. It is not a microcontroller, it's a development board again. They are same using the Cortex, ARM Cortex M series, like same like things, 2 MB of flash memory and 520 KB of RAM and all. So this is the basically overall things. And now I'm going to show you the each microcontroller. Okay, just allow me time of the 2 minutes. I will share my camera and all. Huh? Okay, I will just allow me 2 seconds. Huh? And till that, if you have means if you want to ask something, not ask is it understandable for me? If, for you, like you can connect with me or like not, just tell me. Yeah, yeah, I'm ready for your reviews. And okay, I noted this question. What is the EEPROM? I will, yeah, do it. Where is the Kshitij, bro? Kshitij, just
Hello. Yeah.
just give me 2 minutes and host for the 2 minutes. I will connect with my mobile and take the components on the table. Okay, just for the 2 minutes host
Okay.
it.
Okay.
Okay,
Okay. Okay.
okay. Just host it and ask any queries and all. And note it and I will be there. Just a 2 minute. Okay.
Hello? Am I audible?
Yes.
Hello?
Yeah, you are audible.
You can open your mic, guys, huh? You can open your mic when I am speaking. Hello?
Yes.
Soumya. Okay, okay. So the host is coming back in a minute. There's some technical error going in the background. Till then, let's play a game. Okay?
Okay.
So I'll guess off a city. Anyone who let's say guesses the city first wins. Okay? Simple game. Simple game. Okay. In three, two, one. Just name a city. Name a random city. Let me open a poll. Is it
Kanpur.
is Nana? Let me open. I'll give out polls. Arey, wait, yaar. Wait. City.
Hello, guys.
Arey, wait, Utkarsh, we are playing a game. Wait a second.
Okay, okay, sure.
Wait. Okay. Launch. I am thinking of a single city from these four. Let's see how many people win. Come on, guys. I've given you the vote. Poll. The it's 8:29. At 8:30, I'll end the poll. Okay, I'll end the poll. So within 1 minute, with this this stupid game would be over. I don't know how I came up with this. Okay, vote,
Bro,
guys. Come
what are
on.
you
We
doing
are
here?
how many people are here? We have 66 people in the meet and only 21 votes. How is it possible? Come on, man. Poll. Vote. Come on, guys. Vote. Select a city. Select a city that I'm thinking of. Is it? Is it? Is it? Okay, it's 8:30. Let me end the poll. And I was thinking of Ahmedabad. Kanpur. Come on, yaar. Kanpur kahan se aaya? I was thinking of Ahmedabad. By the way, I live in Ahmedabad, so yes, obviously, I was thinking of Ahmedabad. Okay, Utkarsh, are you back? Utkarsh, is everything all right? Hello, Utkarsh.
Yeah, yeah, yeah. Hello.
Okay,
Just a
so
minute. 1 minute. Wait. Everything is okay, but I'm just placing the microcontrollers on the table. Okay. Camera is there. Okay.
okay. I study in Hi Diksha. Then let's meet one day or kya? Did you not come to Ahmedabad meetup? I hosted a meetup from Namdafa house. After after we just hosted guys, whoever was in or near Ahmedabad, we hosted a meetup in Ahmedabad yesterday on Gandhi Jayanti.
Hello. Sorry to interrupt you guys.
Okay,
Kshitij? Kshitij?
let me
Yeah,
let me
Utkarsh.
give it back to Utkarsh.
Actually, see, I just turn on my camera, so can you pin it, please?
It's already pinned. Like you can turn it on.
No, no, I actually joined from the other device, actually.
Oh, other device. Okay.
Uh,
So its name like
My name, what's the name, sir? Utkarsh system.
wait, let me see.
Okay. What did you get?
No.
Okay. did you get it? Yeah. Just
Yeah.
give me a second, please. Okay.
I pinned it.
Basic. So basically, see, I think everything is visible. So first of all, I will tell you about the Arduino board, right? So in the market, when you go and buying a new Arduino like board, so basically you will get this kind of boards. This is the basically overall Arduino board. Okay, it's a very small and tinier size board, which is fit on your palm, as I told previously. In the market, you will get two different kind of boards. See, this first board is where you can see the kind of large IC was embedded over there. As we saw in our slides and all, this particular large IC is over there. But in the other kind of board, what happens? I think video is pinned out. Technical
Okay,
team.
sure. It was my mistake. I'm sorry. I apologize. It was my mistake. I
Okay,
was
okay.
trying to pin the video.
Okay.
Where, where is the video? Let me check it. Okay.
Sure.
Which presentation? May print to screen and not
Sure, sure.
this. Uh, but which name were you showing? Okay. Done now.
Okay. Now see, there are two different type of Arduino boards are. Sure. I will stop representing. That's a good idea. Okay. The two different types of boards you will get. The first one is over there. There's the SMD kind of microcontroller embedded over there, and there's a large microcontroller. Basically, nowadays the boards are coming. Basically, not coming like we are importing from the China and all. So these are quite, I think, cost effective or not like that thing. So basically, right now we will get this kind of boards where the IC is the same microcontroller used in the both boards. Uh, but yeah, the size of the microcontroller is a difference. Now, if I will talk about the Arduino Nano, right? We talk to you about the Arduino Nano. So see, this is the Arduino Nano. It's a very tiny. If I'm comparing with my finger, so it is tiny, such like that. This is the Arduino Nano. Basically, it is used in a such kind of project, like when you actually need a kind of thing, like you need a very short and tiny any project. As I told you, like smartwatches. But yeah, smartwatches for the smartwatches is not a good because it is too big for the smartwatches and all. But yeah, the other thing is like if you are developing a flight controller for aeroplane, you have to think that the size is basically make a important role at there. Weight also make an important role. So then most of the flight controllers, most of the not if you are making your own flight controller like for the RC planes. So this board is basically very helpful for that. Okay, this is the Arduino Nano. And you might have been surprised if it is Arduino Nano, then what you need a thing like if you want to build a project which does not have distance like that. So what this comes Arduino Pro Mini. See the size of board. This is the overall microcontroller board. This is known as Arduino Pro Mini. So it is a very tinier board. Means very. There's a one more microcontroller comes that the name is Atmega 80 tiny microcontroller. So this is very. It will be very short, and each and everything you can do from this microcontroller. Whatever thing you can perform this microcontroller, the same thing performed by this microcontroller. And these are the basically Arduino series microcontrollers. And the Arduino series microcontrollers, you might have know about the Arduino Mega, which is one of my favorite boards. This, see how big it is. So this is basically Arduino Mega. Arduino Mega basically have lots of pins, like analog input pins and all. So lots of pins are there. So see, there is a kind of serial communication pins. I will show you. Okay, just place the light forward. Yeah. From here, from here to here. Okay, from here to here, there's a kind of a bunch of serial communication. You can connect to four different serial communication sensors. Means a UART sensors. It is it is very kind. 1 minute. Four different sensors, and in the chat box, anyone asking about the power consumption. Yeah, don't worry about the power consumptions. These boards are designed in such a way they will consume very less amount. The kind of, if you are using the full potential, so not a full potential, but yeah, generally it will consume like 10, not a 10, but 100 under the 100 milliamperes of current. It depends on what pins you are using. If you are using every pin, the current consumption will be very high. If you are using only one pin, the current consumption will be low. In the Arduino and the other microcontrollers, there's a thing called the deep sleep mode. So in the deep sleep modes, when you activate the deep sleep mode of, let's suppose this Arduino Nano, when you enable the deep sleep mode, so deep sleep mode, what it did, when it will say to the microcontroller, hey microcontroller, just do a particular task and uh, sleep for 1 hour, then wake up, then do task, then sleep. So what happens? Only the 1 minute time period, like first 1 hour's 1 minute time period, it will do task, send the data, and then going sleep. When it is in the sleep mode, the in the sleep mode, the power consumption will be less than the 1 microamperes if you are using such kind of things. So quite sensors and quite devices are there, like if you are building a device for the flood monitoring, so place on the river, and they forget it to change their battery till the 2 to 3 years. It will easily work on the single battery to 2 years. How? With the help of that. So they designed in a such a way that they can give a maximum efficient things. Okay. So don't think about the power consumptions and all. Yeah, there's a kind of ESP32 we have. That, see, this is the overall ESP32 board. For the connection, so port is there. You can easily connect with the USB cable, connect with your Arduino and all. Sorry, computer PC and all. This can easily programmable. Yeah. And ESP8266 also, I told you. This is the ESP8266. See, it's a smaller version of this ESP32. The thing is, the differences between this and this microcontroller, that it don't have a Bluetooth functionalities and some less memory constraints, and everything is okay. Everything is same task it can be done, but some memory constraints are there, and Bluetooth and all. Okay, now the third microcontroller we are getting, not third, not, I don't know what's the number. So now the next microcontroller is a Raspberry Pi Pico. See, this is the Raspberry Pi. It is also it is a similar kind of Arduino Nano, but yeah, it is some bigger version of. Okay, size difference is okay, but yeah, some bigger than that particular. Right. See, everything is okay, but yeah, some bigger than. But it has dual core. Means you can perform two particular tasks at simultaneously. Indication analytics and all. Basically, not Arduino, the Raspberry Pi Pico is especially designed for the MicroPython. Basically, if you want to program, you can program it via Arduino IDE also, no problem. But yeah, initially the companies basically suggest to program it the MicroPython language. So we are not focusing on the MicroPython in this workshop. In the fact that if we do, we will see. But yeah, you can also program it using the MicroPython. Now I am telling you guys that there are many companies that are building their kind of uh, development board with the open source like things. It means Arduino is the open source. So see, it is similar like a Arduino, right? VMOS company make it. It is the similar like Arduino, but same pin configuration, same the cutout, same the DC jack and all. But what they changes, they change their microcontroller to the ESP32. Just see, see everything is okay. Just they change their microcontroller. That is the benefit of the open source thing. So it is a VMOS series microcontroller on the basis of the Arduino. So these are the microcontrollers, and uh, you know, guys, that we can make the projects. We can make the projects with the help of this. So I will also share you with some projects and what kind of projects you can do with the help of these microcontrollers, and some of the projects are there. So I'll show you. Okay, I will show you. Just okay, right. See, first project is this one is that line follower robot. Basically, what it did, it follows the line. Means you on the floor, you just tape it out, and it will basically follow that particular line. There's a kind of two sensors over there, like infrared sensors. See, at the bottom of the at the top of this particular, see there are two sensors. What these sensors did, they just detect the basically black color. Line is a black color state. So black color, what it did, you know that black color is basically the best black body like thing. Means it absorbs every raises which is coming from the light and visible spectrum and all, right? So it just what it did, it just when a line comes with the range of this particular sensor, it detects with that particular thing. Okay, and send data to the microcontroller. There's a ESP series microcontroller over here. See, who is the person? Switch it. Okay. And also this is the and also like this motor driver and all. So like we can make a more project as well. Like this is the car which can controlled by with the help of your mobile. You can write on. This is the anti-collision board. See, it will connect with you. Not to connect, it will restrain themselves by collision. Okay, so I will stop this sharing and all. I will share you video last in the last. I will share you video working of this that particular projects. Then I'm over it. So just turn on this camera. Okay. I'm leaving it. Yeah. If possible, make a video and send it on the group. Okay. I will send on the group. Sure. Just only 1 minute.
So are we starting Q&A sessions?
No. Just 2 minutes video. So I will show them Q&A statements will be
Okay.
start. Okay.
After the presentation, right? Okay.
Yeah. After the 2 minutes. Okay.
Okay, sure.
Okay. So it is visible for everyone.
No,
It is visible, right? Yes.
now it is.
Okay. See.
Hey, try.
This is the.
Before you start, is the video copyrighted or not? I mean, like this is also going on YouTube now.
No. It's my own personal videos. These basically projects is made by me all. No. So this is my captured video, not a. Okay. See. What is. Okay. See. See, this is the line basically which this bot is going to follow. Like just I place it on that particular line, and it's just starting to follow that particular line. See, right? These are the good projects, initial level project that you can do for your beginner level projects. It's give you lots of learning about the microcontrollers and the sensors and all. See, is sensing and taking the decision as per the things, right? So one more video I will share then toward to like this is the pathfinder robot, which basically find the obstacle. If there is an obstacle comes, so what it did, it stops. Like it stopped. It thinks, seeing that which direction the object way is clear. Just stop. See in which direction the part is the thing is clear. Basically. Okay, so yeah, just it work like that. And then one more like robotic arm like projects. I told you about the PWM signals, right? So the PWM signals comes. You see this robotic arm, the servo motors are there. So basically, servo motors, when you control the servo motors, so you need a PWM signal. See? So these PWM signals basically generated by your Arduino. So you can connect that particular pin by seeing the data sheet and all. Okay. These are the projects, and in the further workshops, we will learn about how to code. This is the basic of the workshop and all basic things that beginner levels have to know about the microcontrollers. In the initially, uh, I think it's a time for Q&A session, right, Kshitij?
Yeah, Utkarsh.
Sure. I will share. I will share
Hello.
these things, and if I will try that, you guys will make this project. Yeah, this will makes you kind of. This will provides you lots of learning. I will. No problem. I will share you the group. Okay. So now I'm overing to the Kshitij. Kshitij.
Yeah, Utkarsh.
Huh. Absolutely. I will share.
Hello.
Huh.
Am I audible?
You are audible. Now,
Yeah.
if anyone have a doubt and also, yeah, sure. Just send me an invite
If
to,
anyone have doubt,
yeah.
then you can ask it. You can ask it directly,
Okay, actually,
or
I
you
think
can type it in the
there's a
chat.
team. I think there's a team which is dealing for the. Okay, then write in the chat box. I will see.
Write it in the chat box, or you can also unmute your mic and say it.
Hello,
Hello. Hello.
hello. I want to ask, is am I
Let's
audible?
see. What is the audible. Just ask.
I want to ask, is this workshop beneficial for the data science students, or it will only beneficial for the electronic students?
See. Data science and electronics, basically, one thing is common in both is the programming. So, if you want to learn about programming, which actually deals with uh, the microcontroller levels things, so yeah, it would be beneficial for you. And basically, you are going to learn some new skills, right? So, not a very straightforward answer, but yeah, it is beneficial also. uh, Tips on electronics and physical science to influence AI electronics. Bro, if you want to influence the AI with the electronics, so microcontrollers cannot do such kind of things because the connecting with the AIs and all, you can do some small kind of work on the ESP because it has the ability to connect with the internet. But if you are thinking like you want to make some deeper projects like like OpenCV based on all AI project like. So you have to shift yourself on the microprocessors. Okay, like microcontrollers is not a good choice over there. Could you tell difference about analog? I told you now, analog signals are basically those signals who basically in the range of a particular zone, like 0 to 5 volt, 1 volt to volt 1.3. So this is the analog values, and the digital signals only two: zero, either 0 or 1; the 5 volt, either 0 volt, only one. Does Arduino board also use a big industrial project? No, 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 no. Arduino boards are not used in a big industrial project. If you want to build such kind of thing, you can do. In the big and industrial level projects, basically, you might basically that embedded C is there, like STM series microcontroller are largely used in the industry level, STM series and all. What is EEPROM? EEPROM basically electronic erasable programmable read-only memory. Basically, see, when you want to store a data, like I will tell you, like see your example of your computer. You are working in your MS Word. Suddenly, you shut down your laptop without saving this. So at that time, when you're working your MS Word, so the entire your data and your things are saved on your RAM, right? And if you're not saving it, close it, a power supply is gone, you everything is lost. So like flash memory is sorry, SRAM is that kind of thing, and the EEPROM is like you saved that particular project in a hard disk. Now, anytime after switch off your computer and anytime you turn on, you can access this. So it is non-volatile memory,
Uh,
and
1 second,
flash
Utkarsh, one
memory.
second. Sorry to interrupt. So I'm just closing down the this thing live stream. It's fine, right?
Okay, it's a 9 o'clock, right?
Okay, thank you, thank you. You can carry on.
Okay,
You can carry on.
okay, okay. Sir, what is the mean by flash memory? Okay, the flash memory, flash memory where basically you write a program. Program is going to shift. Basically, program basically not going to shift is a kind of thing that the program is basically saved in a microcontroller. But the program, in the sense, sets of instructions is saved in the microcontroller. The place where it's saved is known as flash memory. So, any other doubts? So. Any other doubts? So, otherwise,
Hi,
I
sir.
will. Yes. Hi.
Sir, actually, I am pursuing my BTech in electrical and electronics engineering and doing
Okay.
this DS and BS in data science. So,
Okay.
I'm thinking that electronic system is good with BTech in Triple E or that data science. Because I'm just thinking to switch
Electronic
from.
systems. Obviously, electronic systems. We have from electronic systems because lots of topics are quite common with the electronic systems and all. DS, I think one or two subjects may be common, like some C programming
Mathematics.
and mathematics. And in the electronic systems and electrical engineering, so 70% syllabus is common.
Because it is making it hard to manage both of the things. And if the exams are clashing on, then it is really bit difficult to manage
Yeah,
both of them.
yeah.
So I am right now in foundation term two level. Is it good to switch from after completing foundation to electronic system?
Most welcome. Electronic system, but if you can carry on that particular DS program, then carry on, and if you think that it will be overburden, then depend upon you. Basically, in the electronic system, the same things are written.
Okay, thank you.
We have to query in future. I will share my email ID on group, so you can contact me. Okay, with the group I will share. You can contact me. Okay. Okay, so one question from my side. So, guys, are you enjoyed this workshop or not? It is boring kind of thing. Yeah, first workshops is, I know the concept are there. Did you enjoyed or getting new things? So just Tell me. Okay.
Yes, we really enjoyed it, and it's quite informative.
Okay, okay, okay. So I think the tomorrow session I
Yes,
planned
sir.
like
Wonderful session.
tomorrow session I basically planned for doing some other experiment like LED blinking ports. Then you physically see how you are dealing with these things. And I'm also planning to how to control a motor with the help of this microcontroller. For example, if you're building a remote car and if you want to control that particular thing. So how would you complete this? How would you control this? And how control like signals and all. So tomorrow's session will be more informative. So, so okay, we think like it's a nearly 9 o'clock. So Kshitiz, I'm overing to you.
Yeah, I think it's completed. Like, Sushit, uh, hello. Okay, let me call him.
Hello. Okay, Kshitiz, so carry forward. And,
Yeah, wait, Utkarsh, can you wait at least 2 minutes? Okay.
absolutely, absolutely, no problems, no worries. Should we prepare
Thank
the
you,
topics for
to
the
accept
next session?
thank
So
you
for
to
the next,
accept our invitation and for a wonderful session.
especially thanks to you and your team for inviting me as a guest speaker. I'm highly obliged to your team for giving this wonderful opportunity to the Kshitij and Hariom and the Priyams, the secretary of the society and all. And thank you very much to all of you. And, right. And one query is short. Should we prepare any topic for the next session? Okay, yeah, I will give you a task. Okay, just do what the thing. Go and search about the blinking code of the Arduino, how the LED blink, and try to think about the connections and all. Okay, this is I'm going to tell you. And those who have Arduino, okay, and the laptop. So in the tomorrow session, what you do to take your laptop and come with Arduino, and also turn on your laptop, install application. His name is Arduino IDE. I will send the link. Okay, on the group where you
Should
can
I share it?
download the
I have it
Arduino.
on my PC.
Okay, okay.
Wait a second, let me show. I don't, luckily, I hold a, I don't have projects on this laptop app per se, but let me just show them the, you know, interface. है ना?
Sure, sure, sure.
Something like this. You guys will get. I have a few projects in other laptops, so I guess it is visible. Is it visible?
Absolutely, absolutely, it is visible.
Yes, sir.
Like if you guys have seen it, let me stop sharing. Sorry for interrupting.
Okay, okay, okay. No problem. At tomorrow session, we will learn about deeply, and you
Utkarsh,
will.
thanks for coming,
Yeah.
bro.
Okay, okay.
Okay, so guys, any more questions? Like any general questions would be resolved in the WhatsApp group itself. We have exceeded the time limit given to us. Uh, I would, humbly thank you all. I would. Oh, let me open my open. Okay, okay. Give me a second. Just tell me when I'm visible. Okay. So I would thank you guys for attending this meet. I would thank Utkarsh first of all. He did the hard work. We guys are just the backup. Okay, and general queries would be solved in WhatsApp group. Do do ensure that you follow Namdafa's social media handles such as Instagram and LinkedIn. Do follow Sayog and meet you all at the next session of what's it called? Oh my god, I forgot. Shit. What kind of host am I? Okay. Okay. Let's meet you. I'll meet you guys in the next session. Okay. Peace.